Hi everyone, welcome back after a long time. This is going to be a short tutorial. Here I'll show how to optimize a molecule in the excited state. This is the Stilbene molecule. So we have already optimized the molecule in the ground state. So now we'll optimize the molecule in the excited state using the TD-DFT method. So we'll be using Gaussian view and Gaussian for the process. So in Gaussian view, go to the calculation setup, the job type optimization method. Here we'll be using TD-SCF. So we are using a very simple basis set 631G-D, and we can choose the state if we want to optimize in the singlet state or triplet state. We can choose from this option. So suppose we want to optimize the molecule in the T2 state, then we have to choose triplet only. And here please remember the spin state will be singlet because here the TD-DFT calculation will be based on singlet ground state reference. Okay, now we have to choose the state of interest. So suppose we'll optimize it the T2 state, so we have to choose 2, and now let's compute the lowest 6 triplet excited states. Okay, so this is the setup. Now we'll save this file. So we'll optimize the molecule in the supercomputing server. Okay, so we have to save it in the .com format. So I'm renaming this file. Now I'll use WinSCP and PuTTY to run the job in the supercomputing server. So using WinSCP, I'll transfer the file from the local computer to the server. So it has been transferred now. And using PuTTY, I'll submit the job. So first you have to open the script file and then edit the file name and then submit the job. Now the optimization has been completed, but we didn't find any significant changes in the geometry. Only some of the bond lengths have been changed. For example, this CC double bond length has been slightly elongated from the ground state geometry. Okay, and please remember that I have not performed the frequency calculation because it is quite common to encounter imaginary frequencies when optimizing higher excited states. I hope this video will be helpful for you, and thank you for watching.